Hi Tala, just wanted to go over your paper for you. I hope this volume is up. Just let me check. Yep, okay. First off, we're trying to find the pipeline through here, through the middle of our triangle, quadrilateral actually. The problem is it's not a right angle triangle, so we can't use Pythagoras here. You only know the 62 degrees. So you've got two sides, you're finding a third side. So when you have three sides in an angle, we use the cosine rule. So that's how we find the length here. And our cosine rule, a squared equals b squared plus c squared minus 2bc cos of a. Okay, so when we're using this rule to find the length of the pipeline, you're going to have a squared equals, and our a is always opposite the angle, so this one would be a because it's opposite our angle 62 degrees. The two sides b and c are next to the angle, so that's 40 squared plus 50 squared minus, now I usually put this in brackets when I do it on the calculator, 2 times 40 times 50 times cosine of 62. Then you'll come up with an answer for a squared. Remember that you have to square root the answer at the end. And then you'll find that the length of the pipeline, I think, is around 47.1 meters. Sorry, 47.1 meters. Again, looking at your answer, the two sides are 40 and 50 in the triangle, so your side of the pipeline length should be around 50 meters. When you look at your pipeline length here, you should have thought, wow, that's far too long, extremely long, and it's in meters squared, which is an area. So you should have had an answer of something like 47.1 meters there. Try it again. Remember to put, if you're putting it all in your calculator, put brackets around the part that you're subtracting. There. Try that one again. The next thing we have to do, we've found the length of the pipeline. You go to the next page. This was correct. You used the right formula to find the area of the first triangle. Just make that one as squared because it's an area. Remember, area is always in squares, and the pipeline's just in meters. So that was fine. Part of the problem, you had to find the area of the top triangle, and there were no measurements on it, so we can't say that this was 62 degrees up there. So unfortunately it wasn't that easy. We couldn't just use that formula. We had to find that angle in the top triangle. So let's triangle. I knew the top triangle ABC. I had worked out that this pipeline was 47.1 meters, and I was given the other two lengths. 3 lengths and an angle is the cosine rule again. This time I'm using the cosine rule in the form you can see here, where we've got the cosine of the angle, because I'm finding the angle. I don't need a squared. This is a. I already know small a, but I do need to find the angle. So that's why I start with the cos a. And so you can just fill this in. The cosine of my angle is b and c, again, are beside the angle. So 36 squared plus 55 squared minus, always subtract the length that's opposite the angle, 47 squared divided by, and again I put this in brackets because I want to divide it by all of this, 2 times 36 times 55, because of my angle, equals, it should be 0 point something. Usually you'll find an answer there, and I'm trying to remember what the angle comes out to. Can't remember. Anyway, you should be able to find that answer. Is it 57.9? 9 degrees. There we go. So try and find that. The part you had to do was, okay, you found the area, you could find the area of the both big triangles. Now you have to divide the triangles. One way you could divide your triangle, this is triangle ACD, you could have divided it through the middle there, but you need to show the areas. If I divided it down the middle, then this side here would be 20 and that side would be 20. And then the area of, let's call this triangle 1 and triangle 2. Triangle 1, the area of that is half, whoops, sorry, my pen's going off, half times 20 times 50 times the sine of 62, and that equals 441.4 metres squared. That's fine, it's over 400 metres square. Now, to find the area of triangle 2, I know my total area, the black triangle, is 882.9. If I take away the area, if I take away this triangle, 441.4, that leaves me with triangle 2. The area of triangle 2 is 441.5 metres squared. Okay, now for marital excellence, you need to divide this so that they're not all triangles. So let's try what we're going to do. If I divide this, let's say it needs to be about there. It's almost in 2 halves. I've got a triangle and another quadrilateral shape. So I know my total area of ACD. I'm going to work out this area. Now let's make that, this side length, I need to make it a bit bigger than half. Make this side length 20, or I might keep that at 20 and make this one 35 metres. So if I have a triangle that's 0.5 times 20 times 35 times the sine of 62, that equals 309 metres squared. Now that's not quite big enough, so let me try. I'll make it the triangle a bit bigger. And let's see, we'll do there, let's make this side 30 and this side 35. So this area is then, if you work that out, 0.5 times 30 times 35 times the sine of 62. The area is going to be 463 metres squared. Now that should be fine. I want to find this area out. Do that one in red. It's going to be, the total triangle is 882.9. Take away 463 equals about 419 metres square. And you do the same thing with the other side. You've already worked out the angle in the other large triangle, and you can use the same method to work out each section, what the area is. Okay, I hope that helps. We'll catch you tomorrow, hopefully. Bye-bye.